Hi everyone, my name is Shanmukh and this is my project for MSDS 692 at Regis University. Today I'll be talking about a hybrid recommendation system I built for e-commerce platform. I want to frame this project not just for the machine learning tasks but as a real product problem. How we recommend the right products when user data is limited, noisy and inconsistent. Let's start with the problem most of us has experienced personally. Online stores has thousands of products, but recommendations often feel repetitive and irrelevant. Many systems rely heavily on what's popular, not what actually you like. So this becomes even more worse for new users. When there's always no interaction of data, the system falls back to generic bestsellers. That's what you see most of the time. The result is choice overload, frustration, and users leave the platform. So, personalization really matters because it directly impacts the user's experience and business outcomes. If recommendations don't feel relevant, users lose trust and stop engaging. But when recommendations are timely and meaningful, users explore more and more and more and stay longer and more likely to convert. So, personalization isn't just a back-end technical problem, it's a user experience and rentation problem. So, what I built here, it is a hybrid recommendation system. While working on this project, I noticed few four challenges. User interactions are sparse and noisy. Popularity based systems ignore niche interests. Cold start users don't have enough data. Single model approach struggles in real world systems. Each of these problems alone is manageable, but in real e-commerce platform, they happens at all the time. So that's why I designed the system which combines multiple signals instead of relying on just one recommendation method. For data, I used real Amazon Electronics review from Stanford Snap dataset. This dataset includes tens of thousands of reviews along with the ratings, review text, helpful votings, timestamps, and product meta like titles and categories. Earlierly this project, I also used stimulated data just to validate the pipelines, but all final results are based on real world e-commerce data. So this slide shows what the data actually look like in practice. First, most reviews are 5 stars, which means the data is heavily skewed and doesn't give more contrast between the products. Second, most users leave very few reviews, while a small number of products review little interactions. This creates a uneven interaction patterns. So you also see the reviews increased over time and the growth isn't evenly distributed across the users and the products. Finally, the length varies significantly, showing that user feedback is inconsistent and noisy. Overall, these patterns confirm they're messy in real world data where the simple recommendation methods are likely to struggle. The feedback, this slide summarizes how the system works end to end. First, I created the impulsion feedback features by combining rating, reviews helpful, and reviews length and recency. This helps extract more meaningful signals from limited data. Then I built baseline models such as popularity ranking and matrix factorization to establish a reference point. After that, I added content based modeling using product titles and description to understand product similarity. Finally, I combine all these signals into one hybrid ensemble, which allowed the system to remain robust even when the signals were weak. So here you can see examples for recommendation generated by the system. Instead of simply showing popular products, the system recommends item for content relevant. For example, this user browsing TV accessories re- receive recommendations like HDMI cable or streaming devices. This shows the model moves beyond the popularity and focuses on what intent and relevance as well. On this slide, I'm comparing how different recommendation model performed. Lower error means better prediction. What we see here is simply popularity based and collaborative model struggle, mainly because the data is sparse and user behavior is inconsistent. The hybrid model performs best across RMSE and MAE because it combines multiple signals instead of relying on just one. That makes more stable and more accurate in real world conditions. To evaluate performance, I used standard metrics like RMSE and MAE along with offline comparisons between baseline and hybrid model. The result shows the hybrid model remains more stable than other models, especially for the sparse and cold start users as well, which is the critical for real world development. To wrap this up, I built a hybrid recommendation engine designed for real world e-commerce challenge. The feature based hybrid model significantly outperformed baseline approach and more predictable accuracy nearly 58%. More importantly, the project showed the recommendation systems are less about finding perfect algorithm and more about combining imperfection signals in a thoughtful way. So to reflect on this project, the biggest takeaway for me is to understand how challenging real world recommendation data actually is. User behavior is sparse, rating are biased, and relying on single technique doesn't work at all while in the practice. What my hybrid model was bring together is multiple signals, uh, user interactions, product content, and popularity trends as well, instead of depending on one source of information. This allowed my system to handle cold start users better, capture niche interests, and remain stable when data was limited. Overall, the project showed me the effective personalization isn't about most complex models, but about designing a system that works well under real world constraints. In conclusion, this hybrid approach demonstrates a practical and scalable way to build recommendation systems, which is balancing the accuracy, personalization, and robustness. Yeah. Overall, this project helped me gain a much deeper understanding how recommendation systems behave in real world environments where that data is noisy and imperfect. It showed me that relying on single approach is really enough, and the hybrid models are essential for building scalable, reliable, and user friendly personalization systems. Working through these challenges gave me a valuable insight into designing practical solutions that can perform well outside of control and ideal conditions. And thank you for giving me this opportunity.